All right, let's talk about a new kind of threat, one that your standard security playbook is completely blind to. We're going to dive into a critical risk for AI systems that has nothing to do with flooding your network. It's a much more subtle and, frankly, way more expensive attack that goes right for the computational heart of your AI. So here's a super simple way to think about this. A traditional DDoS attack, that's like 1,000 people calling a restaurant all at once to jam up the phone lines. It's pure volume. But an AI denial of service attack, oh, that's totally different. That's one person calling up and ordering some ridiculously complex 3-hour dish that brings the entire kitchen to a grinding halt. While your chefs are sweating over that one order, nobody else gets to eat. The attacker made one cheap phone call, and you're left with a massive bill for all those resources. And look, this is not just some theory we're kicking around. This is a real number from a real incident. Yeah, you're seeing that right. A single, carefully crafted attack racked up a $340,000 cloud bill in just 11 hours. This is a purely economic attack. And for any manager out there, that number, well, that should set off every single alarm bell you have. This is a massive business risk we have to get ahead of. Okay, so the big question is, why? Why are our shiny new AI systems so wide open to this kind of attack? Let's break down the fundamental weaknesses that attackers are already jumping all over. Well, the first and most critical concept is something called computational asymmetry. It's a fancy term, but it basically means the attacker has a massive, almost unfair advantage. It costs them practically nothing to create a malicious prompt, a few seconds of their time. But for you, the defender, processing that one prompt can cost thousands of times more in super expensive GPU time and, you guessed it, cold hard cash. The second piece of the puzzle is what we can call token economics. With a regular old website, one request is pretty much the same as the next. They're all kind of cheap. But with AI, no way, not even close. A simple 100 token query is pocket change. A complex 100,000 token analysis, that's a massive expense. And that right there is exactly why our traditional security tools just fall flat. Which brings us to this huge, and I mean huge, misconception I see all the time. A lot of leaders think, hey, we've got a CDN, we've got IP rate limiting, we're all good. Let me be really clear. You are not. Those tools are just counting the number of requests. They have no idea what's in the requests. And when one malicious request can cost 1,000 times more than a normal one, just counting them becomes totally meaningless. So, we get the why, we see the weak spots, now let's look at the how. How do attackers actually pull this off? We're going to dissect the anatomy of these attacks, because they really come in 3 main flavors. This table really lays it all out. You've got your sponge or token bomb attacks, you've got compute-heavy prompts, and then this really nasty one called model degradation. But just glance over at those last 2 columns. The cost multipliers are just, wow. We're talking 10x, 200x, even up to 500x. And trying to spot them in real time? Yeah, that gets pretty hard. So let's break down that first one, the sponge attack, or token bomb. This is exactly that restaurant analogy in action. The attacker sends in a prompt that seems harmless, but it's engineered to trick your model into a recursive loop, forcing it to spit out a massive, super expensive response. One little prompt ties up your GPU resources for minutes instead of seconds, and suddenly your costs are through the roof. Now this next type, the compute-heavy prompt, is a little sneakier. This one isn't about generating a huge output. Instead, it's about making the model think really, really hard. It cleverly abuses legitimate features, like chain of thought, to send the AI down this deep, complex rabbit hole of reasoning. It just sits there, churning through your expensive GPU cycles, multiplying your compute costs by 100 times or more, just thinking. And finally, we have what might be the most dangerous one of all, model degradation. This one is super stealthy. It's not about a big, noisy spike in your bill. No, this is where an attacker slowly poisons the data your model learns from. The damage isn't temporary. It's a permanent flaw that gets baked right into your model, affecting every single user. It's like a slow-acting poison for your core AI asset. Okay, that is a lot of scary stuff. I get it. It's complex, it's dangerous. But here's the good news. There is absolutely a way to defend against this. It all comes down to a really practical 3-layered defense strategy. Just think of it as defense in depth. And it's pretty simple to remember. First, you validate your inputs. Stop the bad stuff at the front door. Second, you manage your resources, so you can limit the damage if anything slips past. And third, you monitor and respond. You need an alarm system to catch anything that's happening right now. So layer 1 is all about being a smart bouncer at the club door. This means you have to set strict limits on how many tokens can go in and how many can come out, especially for different types of users. You can even get smart and use heuristics to spot the signs of a complex prompt. And this is key. You can pre-calculate the estimated cost of a query and just reject it before it ever touches your precious, expensive GPUs.
And let me be crystal clear on this point. This is non-negotiable. You can never trust what the client asks for. You must enforce a maximum output limit on your own servers. This one simple control is probably one of the most powerful things you can do. It single-handedly stops the vast majority of those token bomb attacks we talked about.
Layer 2 is your blast shield. It's all about damage control. If a bad request sneaks past your bouncer, you need to contain it. This means you implement quotas based on tokens, not just the number of requests. You set hard dollar limits for each user's API key. You have aggressive timeouts that kill any query that runs too long. And you isolate users from each other so one bad actor can't sink the whole ship. And finally, layer 3. This is your alarm system. You have to be watching the right things. I mean, sure, you'll look at stuff like latency and GPU usage, but the real secret here, you have to watch the money. Track the cost per user, per API key. Look at the ratio of output tokens to input tokens. A weird financial spike is often the very first and clearest sign you're under attack. Okay, I know we've gone over a lot of ground, so let's cut right to the chase. If you walk away from this and do just one thing, what should it be? Let's talk about the single most critical action you can take, like today. I'll ask you directly, what's your fastest, biggest win? What's the one thing that will prevent that nightmare $340,000 bill from ever happening to you? It's this, the economic circuit breaker. This has to be your number one priority. For every single API key you issue, you implement hard daily caps in both dollars and in tokens. Then you set it up to automatically suspend that key when it hits, say, 80% of its budget. That's it. That one control is the wall that stands between you and a catastrophic surprise cloud bill. And if you need to make the business case to your boss, just look at this chart. The cost of putting these defenses in place, the caps, the monitoring, it's tiny. It is nothing compared to the potential cost of just one successful attack. The return on investment here isn't just good, it's an absolute no-brainer. All right, let's lock this in with the 3 big takeaways. Number 1, AI denial of service is an economic attack, and your old security tools are completely blind to it. Number 2, your fastest, most effective win is that economic circuit breaker. Seriously, go do it. And number 3, you have to start treating your cost monitoring like a security tool. Your billing dashboard is now an intrusion detection system. So I'll leave you with this one final thought, a new principle for this age of AI. Your GPUs, they are no longer just commodity servers. They are incredibly expensive, powerful, mission-critical assets. You have to start defending your GPUs like a bank vault, not like a web server.